Hi, Mike Matchett with Small World Big Data, and today I'm talking about some new vulnerabilities you might want to be aware of, especially if you do something in the cloud, especially if you do something with Golang. Oxeye is always looking for the latest and greatest stuff. Today we have some of their principal researchers in the topic with us today. We've got Ron and Daniel. Welcome, guys.
Hey, Mike. Thank you very much. I'm very happy to be here.
All right. So let's start with you, Ron. We talked to Oxeye before. You guys are always finding new vulnerabilities out there as a service to the rest of the world. Maybe you just tell us a little bit what Oxeye is all about first.
Yeah, of course, no problem. So in Oxeye, we are building a cloud-native application security platform for cloud-native application, which means that we find vulnerabilities in the custom code, in third-party packages, and hard-coded secrets for modern applications that usually written in microservices architecture, deployed with containers, with an orchestration platform like Kubernetes, and in the cloud, and all of that before they ever reach production.
And this is coming about because people that are cloud native are often using a lot of open source. They're using a lot of chains of microservices that they might not be fully aware of or have written themselves necessarily. And there could be vulnerabilities introduced in many different places in there, right?
Totally, because in the past, when you work in a monolithic architecture, a vulnerability started and ended on the same piece of code. But nowadays, we can see that vulnerabilities stretch on multiple microservices. They start on the public-facing API service, and then the vulnerability might go through different third-party components like message queues, Kafka, RabbitMQ, S3 buckets, or even direct connection up to the internal services. So in fact, we're no longer talking just about vulnerabilities, but we're talking about vulnerable flows. And in order to find them, you have to do something differently. You have to do cloud-native way of finding these type of security issues.
I know we could dive down into that specifically with Oxo, but Oxeye. By the way, I have often talked about things as a supply chain of information or supply chain of data, but I like referring to it as you did as a flow of things that you might not necessarily be in control of. But it does actually touch a lot of different folks who might have provided lots of different pieces of code, so it becomes very complex. All right, so Daniel, how big is your team? How many people are working on looking for vulnerabilities and problems at Oxeye?
So basically, our work is divided into different sectors. We also work on like the product security type of work, and our team is responsible for that. And we also have this work to find new vulnerability types, where all the team was responsible for doing this research. And a special props goes to our Star Goldstein, which found this vulnerability in Golang apps. So yeah.
All right. So today you're coming along to tell us about something you've recently found, some hot news about another vulnerability that might affect more people than they think. So Dan, why don't you tell us a little bit about that?
Sure. So we found a vulnerability in Golang-based apps, which we dubbed parse through, mainly because it's a parsing vulnerability in Golang-based apps that under certain conditions lets threat actors to bypass and to smuggle certain requests to a backend service where they originally could not do that. So the vulnerability actually relies on a parsing error in Golang, where before version 1.17, Golang would treat semicolons as a separator for query parameters. Now, this was fixed after 1.17, but they consider now semicolons as a bad character. So basically, when they see a semicolon, they would raise an error. Now, Golang uses an unsafe method that would just ignore those errors and doesn't return the query parameter back to the app. So basically, if someone uses a parameter with a semicolon in the end, that parameter would be ignored, basically. So the app couldn't take any logical decisions based upon it.
All right, so Golang has a couple methods for parsing queries. This sounds a little bit like SQL injection attacks in a way. Like you're gonna abuse this hole in the code by putting in some bad code that you maybe specifically tailored for this. But I'm curious, Golang has several methods for parsing, so they made it raise an error, but their methods don't honor the error in a way?
Yeah, so they offer two methods. The first one does return the errors that you get back, but the second one doesn't. And we found several apps that are using that second method, which was vulnerable to this issue since the errors are just ignored on a couple of different projects. One of them is Harbor, which is a CNCF-backed project, where we found that users that send those requests can actually read sensitive data like Docker images of restricted containers. So they would basically have access to those layers that they were originally wouldn't have access to.
All right, because they're using some semicolon things, the first layer is ignoring them, raising an internal error, but not doing anything about it. That code gets passed to the subsequent or internal application codes or downstream. I mean, we talked about the different kind of web you can make with all sorts of microservices, right? We don't know even where it's going, and come back with an error. How bad is this? I mean, if someone can do this on something like Harbor, which that CNCF project, there could be some very large vulnerabilities out there.
Yeah, so basically the attack surface is really big since the issue is with the language itself and not with a specific app. So every app that uses that problematic function that ignores those errors are basically prone to this type of confusion. So the developer thinks that the app would react in a certain way, and in reality, it reacts on a different way. And if you make any business logic decisions based upon that, you're going to get strange behavior across those different scenarios.
All right, so it sounds like though there's some good news in that there is a safe method that Golang already provides. So is that the remediation path for people that think they have this problem?
Yeah, so if you want like a quick patch, you can either use the second method, which is much safer since it does give you the error back. So if Golang found a semicolon in a query parameter, you would get notified about that. But you can also have like a patchy, method to find by yourself if you have a semicolon. But since Golang offers like a built-in one, you can just use it.
Switch to that. Okay, I understand that that by the time you're telling us, things have already been notified to open source projects like Harbor. Can you just tell us a little bit about your process for telling the world about problems that you found?
Sure. So there is this process called responsible disclosure, which basically means that when we found a vulnerability in a certain project, we get in touch with the project maintainers and we provide them with all relevant information like what is the issue, what is the impact, where does their source code having this issue, and with remediation steps. After we have this kind of collaborative work with them, we work together on a patch, and only when the latest version online is patched and secured, we then ask for permission to publicly talk about this issue.
All right, and the thing here with something that's built into the language, the versions you're talking about, those sound like they've been out there for a couple of years. I mean, this could be fairly widespread vulnerability.
Yeah, so we have seen discussions about this issue roughly since 2018 about not parsing semicolons or ignoring that or not ignoring that. So all those discussions were in the context of how well should you parse your data that is coming upstream. Now, the issue is that no one talked about that in the context of security. So what are the security implications that your app could be suffering from if you're using those methods according to how Golang is parsing the URL?
All right, so you lead a research team. You're constantly looking for this kind of vulnerability and things. Once you find this kind of vulnerability, and by the way, if you've got this kind of vulnerability, we're going to tell you where to go at the end of this episode. But once you find this kind of thing, how does that fold back into Oxeye itself? And how does that make what you do better?
So our research team is basically responsible of making our customers' clusters more secure, and that was the main trigger for this kind of research. We looked for methods or for new types of detections that could find security issues in our customers' code. And this is just one example of this kind of work we are doing, of finding and leveraging Oxeye's unique visibility into our customers' clusters to find out this special kind of issues.
Ron, anything to add to that?
So I would say that new technologies introduce new risk or new attack vectors. And we put many efforts on finding and discovering this type of new attack vector or new way to manipulate and exploit modern applications. So if you're using modern apps, cloud native apps, Oxeye will be able to detect it in your own custom code. And if you are using cloud native assets in version that contains vulnerabilities, Oxeye will detect that as well for you.
All right, so Oxeye is definitely something you should consider using if you are building cloud native applications of any importance whatsoever, handling any data that might be business important, anything that's touching financials stuff for sure, or your business processes. You definitely want to look at your supply chain, your flow of code, and make sure it is being scrubbed for the latest vulnerabilities. All right, so guys, constantly evolving threats, constantly evolving landscape. If someone is interested in Oxeye, which you guys are constantly updating, where would you have them look?
So if someone is interested in learn more about parse-through and the Golang vulnerability, is able to approach Daniel or I directly through LinkedIn or Twitter. And you also can go to our website and read more technical data about the vulnerability in our blog post. And if someone would like to learn more about Oxeye and our product, is able to go to the website, and just register to see the dashboard, deploy Oxeye within their environment, and start to see vulnerabilities pops out in their cloud native applications.
All right, so free test drive if you want to, available from Oxeye. So you got no excuses. Thank you guys for being here today. Thanks for the hard work you're doing, Daniel, on finding new vulnerabilities for us. I'm sure someone out there is going to appreciate, get a heads up and checking and finding that on there. And thank you, Ron, and check it out. You got a free test drive offer from Oxeye. Take care.